You've likely heard a lot about El Niño already, and you're definitely going to be hearing more about it in the months ahead. But what is it? How does it form? And how does it impact Minnesota and global weather? First, we have to understand how air and water circulate around our planet. This is a result of the sun unevenly heating the surface of Earth. In general, heating is greatest at the equator and lowest at the planet's poles. This causes a three-dimensional circulation we call a Hadley cell. Air generally rises at the equator and then sinks some distance away because what goes up must come down. But our Earth isn't a stagnant object. It doesn't just sit perfectly up and down either. It's tilted and circulates. This causes air and water, which both behave as fluids, to move. The result is that things generally move west to east at our latitude, the mid-latitudes, but they move east to west in the tropics and near the equator. This pattern allows surface ocean water to be heated in the sun in the tropics and accumulate in the western tropical Pacific. As water moves west, cold water in the depths of the eastern Pacific is forced upward. This upwelling keeps waters relatively chilly in the eastern tropical Pacific off the west coast of South America. When this normal process weakens or even reverses, this allows warmer water to back up into the central and eastern tropical Pacific towards South America. When this happens, we call it an El Niño phase. The opposite pattern, La Niña, is what we were in this past winter, which is essentially just an amplified version of the normal cycle. The reason all of this matters is because where we have warm ocean water, we have more evaporation, more rising air, and more clusters of thunderstorms on large scales in the tropics. Where these storms develop shifts in an El Niño pattern farther east than normal. Again, when air goes up, it must come down, and that air is carried by upper level winds to different areas. All of this air moving up and down, side to side, creates our global circulation patterns, creating areas of high and low pressure. When these areas of higher and lower pressure shift, so too do warmer and colder air masses and precipitation patterns in other regions, including North America. The biggest impacts are felt in winter. That's because summer weather is often dominated mostly by the sun's heating, but winter weather is impacted more by the flow of air in ocean waters. For North America, this shift allows for warmer winters in Canada and Minnesota as colder air is confined to the Arctic and Siberia. The jet stream also gets energized to our south with the increased heat and moisture. This produces above normal precipitation in California and the southern United States. Globally, Australia and Africa often experience droughts as those belts of storms that are typically farther west shift further east. We see these impacts on wildfires and agriculture too. While some areas benefit from El Niño, most agricultural areas experience reduced yields due to drought or extremes in temperature and precipitation patterns. I mentioned California as an example. This chart shows normal precipitation versus an El Niño precipitation for Southern California. Not only do they see nearly double their normal precipitation in an El Niño winter, but the rainy season often expands from just the winter months typically into spring as well. Because El Niño brings more ocean heat to the surface, spread out, we typically see spikes in global average temperatures in El Niño years. This, combined with climate change, has led to some substantial spikes in temperatures in modern El Niño years. Forecast models continue to predict a potentially very strong El Niño by this fall and winter. NOAA's models forecast a high likelihood of a strong El Niño with a 37% chance of a very strong or super El Niño. The European model is forecasting an even more intense El Niño with a stronger likelihood of a potentially record-setting El Niño. Climate change and our warming oceans are likely amplifying El Niño episodes and their impacts on our local and global weather patterns. And this winter could be one for the record books again.